high-performance liquid chromatography, it is an instrument that we use to separate a wide variety of chemical mixtures. There are several types of HPLC, and one of them is partition chromatography. Partition chromatography, it consists of two modes, which is the reverse phase and the normal phase. For the reverse phase partition chromatography, it involves a polar mobile phase and a non-polar stationary phase. Usually we use silicate gel as the mobile phase, and we use a polar solvent, which is acetonitrile with water, as the stationary phase. To separate the chemical mixtures to separate the chemical components of the analytes, the polar components of the analytes will be dissolved in the mobile phase and will be eluted with the mobile phase from the column, and will be displayed as a peak on the recorder. We begin the experimental procedures by preparing the caffeine standard solution from a stock solution. Next, we prepare the samples. In the stock, carbonation and particulate matter is removed. Third, we inject the working solution into the HPLC instruments to establish the retention times of caffeine. And next, we calculate the peak area of caffeine. Finally, we inject the samples with the same volume as the working solution. And after retention time of the sample is established, we measure the peak area. Identification of samples is carried out by the comparison of their retention times. When a compound is injected, the retention time is recorded, and area of peak is calculated. If the analyte is a compound it's a similar compound as the standard, they will show similar retention times. We also can determine the amount of components present in the analytes by reviewing the ratio of peak areas.
Our objectives are to determine the retention time of standard solution caffeine and to identify the caffeine peak in a soft drink sample, and lastly to determine the amount of caffeine in soft drink sample using the response factor method.
My name is Shafia binti Khairuddin. In this video, I will explain about methodology. For the apparatus, beaker, burette, plasmid, volumetric plus 10 ml, and dropper. And for the chemical, caffeine standard, coach, levita, and distilled water. Next, for the procedure to prepare caffeine standard solutions. First, the stock solution 1.0 mg per ml. 10 mg of caffeine has been placed into a 10 ml of volumetric plus, and then the caffeine was dissolved in distilled water until calibration mark. Then the solution was labeled as solution A. Next, for the working solution, 0.1 mg per ml. 1 ml of solution A has been pipetted into a 10 ml of volumetric plus. Then the solution was dissolved in distilled water until calibration mark. Then the solution was labeled as solution B. Next, for the sample preparation, about 10 ml of each sample has been poured into a small beaker. As in this experiment, the samples that we use are coach and levita. Then the glass ring has been used to remove any carbonation. Lastly, 5 ml of aliquot has been filtered to remove particulate matter. Then, 10 microliter of solution B was injected into the HPLC to establish the retention time of the caffeine. 10 microliter of samples also was injected into HPLC system. This is the block diagram of HPLC. In HPLC system, the flow starts at the solvent reservoir. The pump draws the solvent from the reservoir and pushes it through the system at a constant flow rate, ensuring a steady movement of the mobile phase. The sample is introduced into the fluid through the injector. The mixture then travels through the column, which is packed with a material that separates the components of the sample based on their different interactions with the column. As the sample components move through the column at varying speeds, they become separated. Finally, the separated components reach the detector. This sequence allows HPLC to analyze and separate complex mixture with a high precision. Next, I will explain about the names and the functions of each component in the HPLC. The first one is solvent reservoir. The function of solvent reservoir is to store the mobile phase or solvent used in the HPLC system. The second one is pump. The function of pump is to force the mobile phase to flow through the packing. It is also to maintain stable flow and to avoid pulsation. The third one is injectors. The function of injectors is to put the sample in the mobile phase. The next component is column. Column functions to separate the sample components based on their interaction with the stationary phase. There are two types of column. The first one is analytical column and the second type is guide column. The function of guide column is to increase the lifetime of an analytical column. It is to prevent the activation of the analytical column by absorption and minimize the band broadening, and also to prevent clogging of the analytical column while extending its lifetime. And the last one is detectors. The function of detectors is to measure the concentration of the analyte as it emits from the column and passes through the detector cell.
Hi, Assalamualaikum. My name is Nurina Huda binti Ahmad Syafiq and I have been assigned to explain to you about the results and discussion of our case study. In the next few slides, you will be shown the results and calculations of the RF and the concentrations of caffeine in both Coke and Levita drink. Now, let's have a look. Now, I will explain to you about the calculations. First thing first, let's take a look at the how do you find the RF, which is response factor of the caffeine standard. So, firstly, we have to divide peak area of the caffeine standard with the concentration of the caffeine standard. So, as you can see above, the peak area of the caffeine standard is equal to 6,249.49, and then we will divide it by 100. Now, let me tell you how we get the 100. Working solution provided is equal to 0.1 mg per ml, and remember, the conversion factor is 1 mg per ml equal to 1000 ppm. So, 0.1 mg per ml times with 1000 ppm, we will get 100 ppm that we are using in the calculation above. Now that we get the RF, we can calculate the concentration of caffeine in each drink. First, let's take a look at Coke. To calculate the concentration of caffeine in Coke, we should divide the peak area caffeine in Coke with the RF we get from earlier. Based on the chromatogram, we can see that the caffeine peak in Coke is the tallest peak, which is at the fourth peak. Based on this, we know that the peak area of caffeine in Coke is 7001.12. Divide it by the RF we get from earlier, which is 62.4949, we will get the concentration of caffeine in Coke, which is 112.03 ppm. Now, the same with Levita drink. To calculate the concentration of caffeine in Levita drink, we will divide the peak area of caffeine in Levita drink with the RF we get from earlier. Just like Coke, the caffeine peak in the chromatogram of Levita is at the fourth peak, which is the sharpest peak. So, the peak area chosen is equal to 1.11511 times 10 to the power of 4, which is equal to 11,151.1. Then, divide it with the RF we calculated earlier, and then we will get the concentration of caffeine in Levita drink, which is equal to 178.43 ppm. Now, let's discuss further about this case study. This case study discusses about HPLC, which is High Performance Liquid Chromatography, which is a technique in analytical chemistry used to separate, identify, and quantify each component in a mixture. In this particular topic, there are three chromatograms discussed, which are caffeine, Coke, and Levita. From the chromatograms, the retention time of caffeine can be determined from the results obtained, which is at 2.482 minutes. From the retention time, the caffeine peaks in Coke and Levita chromatograms can be identified. For Coke, the caffeine peak is the highest peak, which is at the retention time 2.481 minutes. And for Levita, the caffeine peak is the sharpest peak, which is at the retention time 2.479 minutes. From this information, the concentration of caffeine in each drink can be determined. Coke has 112.03 ppm of caffeine in it, while Levita drink has 178.43 ppm of caffeine in it. From here, it shows that this case study has achieved its objectives.
So, in conclusion, the detection time of caffeine in the standard solution was 2.482 minutes, which closely matched the sample result. For Coke, the caffeine peak was observed at 2.481 minutes with a concentration of 112.03 ppm. Meanwhile, Levita showed a caffeine peak at 2.479 minutes with a concentration of 178.43 ppm, while high-performance liquid chromatography, or known as HPLC, was effective in this study. Other instruments such as gas chromatography or UV spectrophotometry could also be utilized for caffeine analysis. Additionally, coupling HPLC with mass spectrometry can provide even greater accuracy and sensitivity for future studies. Thank you.